Hello, everyone, and welcome to our Mechatronics Education Community webinar. My name is Zuzana Fabushova, and together with Dr. Nima Lotfi from the Southern Illinois University in Edwardsville, we will be your hosts today.
Thank you very much, Zuzana. Hello, everyone, and this is Nima Lotfi from Southern Illinois University, Edwardsville. As for this webinar, I am excited to introduce Dr. Marilyn Barger, in addition to Gary Morgan, Dan Horine, and Doug Levin, who will be our presenters today. So a brief introduction about Dr. Barger. Dr. Barger is the principal investigator and executive director of Florida Advanced Technological Education Center of Excellence, or FLATE in short, which is housed at Hillsborough Community College in Tampa, Florida. FLATE is funded by National Science Foundation, and it serves technical education pathways and programs in Florida that support the manufacturing industry cluster. Dr. Barger has been developing and delivering a STEM curriculum for K-12 students and educators for over 20 years. She's initiated long-term systematic education reforms. She is a licensed professional engineer in the state of Florida, holds a licensed patent, and has authored 10 peer-reviewed journal articles. She will be joined by Gary Morgan from the College of Lake County in Grays Lake, Illinois, Dan Horine from Virginia Western Community College in Roanoke, Virginia, and Doug Levin from South Central College, North Mankato, Minnesota. So with that, I would like to give the microphone to Dr. Barger, and I'm very excited to hear your presentation.
So good afternoon, everyone. And we did some introductions already, and Nima was kindly introduced my co-presenters. I think it's always good to hear straight from the horse's mouth, so to say. So I've invited three folks from community colleges who are actually running these programs across the country to give us a little bit about what they are doing locally, instead of me trying to tell you what they do. So as Nima said, FLATE is a National Science Foundation Advanced Technological Education Center, and that program focuses on the 2-year technician education in advanced technology area. So advanced manufacturing is in that umbrella, and the goal is to really make sure that the technicians in those all of those advanced technologies that come out of community colleges are really ready to go to work in the industries with their emerging technologies. So we spend a lot of time working together to figure out what those new technologies are coming into industry. We work together as a community of practice across the country in different centers and projects. And typically we put our work in 3 buckets to support the programs, the academic programs at the 2-year level. So these would be Associate of Science degree programs of various names. We'll look at that a little bit later. But in order to keep the program strong, we work in providing good professional development to make sure the faculty are the best and the most up-to-date in technology, pedagogy, etc. We work on curriculum reform and development, again, making sure we have the best materials to give our students, and also do outreach and recruitment, because we still have a lag, a gap in the employment particularly in manufacturing, but in many of the advanced technologies as well at the technician level. So that's kind of what we do. And if you're interested in partnering with the community college, we do work with the 4-year institutions. Part of the curriculum piece is articulation. So you may be interested in connecting to not just the folks here on the webinar, but other 2-year institutions that might provide a pathway of students into 4-year programs. I believe most of the people in this community are in 4-year degree programs. So All right, so I'm going to move along, and I probably need to spend little time on this since this is the Mechatronics education community. But just to set us straight, we're going to be talking about what this looks like in the at the two-year college level. And also, as you know, we put our students in the same industry sectors that four-year engineers go into, or four-year engineering technology graduates. So anything from what you see on this list here: aviation and aerospace, automotive, the new building technologies, consumer products, logistics, energy, green technologies, manufacturing, material processing, etc. You can see the second column, but similar to what you'd expect coming out of any advanced manufacturing and automation related program. So if we stopped and took a look at what's inside a associate's degree, it's of course, it's going to be a little different from a four-year engineering program. We are based on the mechatronics programs are typically based on electromechanical systems. Many of the two-year programs came out of or evolved from the electromechanical technology associate degree programs of the probably a couple decades ago, and added more information technology and communication technologies that now bridge the gap between the different systems in an automated system. So traditionally, electrical or mechanical or electromechanical two-year programs were the source of many of the modern mechatronics programs. Some of them still bear those names and labels. We all know how hard it might be to change the name of a program or a course in an educational institution of any kind, but their focus is much more on
So as previously mentioned, a number of things that we experience is kind of the same. So I'm going to tell you a little bit about our school. We started our program back in 2008, and we started with some seed money from our partners, our industry partners, who felt there was a need for mechatronics in this region in southern Minnesota. And we were also blessed to get a $1.9 million DOL grant, which obviously helped us get the systems that we needed to be to do a good job of having labs that are worthy of having students come in to take those programs. So we had our first students graduate or come into the program a year later in 2009. We are basically loaded in kind of an ag triangle, a lot of healthcare as well, because we have Mayo Clinic and Medtronics in the area. But really, the big employer in our region is manufacturing, but it's a little bit of everything. Even though we have 3M and Mayo Clinic and Cambria, some of the big blue chip players, we have more small little shops at 5 people to 50 people who have a need to have our mechatronics graduates. Anything from foundries all the way through up to medical and everything in between. So it's quite a region to be in when we talk about mechatronics. We have an energy tech program here as well, but 35 of those 60 credits are the technical side of mechatronics. So we're pretty much staying true to our manufacturing partners, but our people can also find themselves getting into the food industry or energy as well. When we talk about distance and face-to-face, I'm in the middle of the slide here. One of the things that we realized is when we were starting our program is that there was a lot of outreaching areas that needed to be reached out to. And we've heard already about some of the costs associated with this. High schools, junior highs, and some of our colleges that we're partners with just do not have the funds. They don't have the grants to fulfill these labs. So we've reached out as well. So we have 2 approaches, and I'm going to talk about those that we took on once we kind of got our feet on the ground with our face-to-face, because you really have to do that first, I believe, before you can start dabbling in some of this distance stuff. We came up with some, really cool names, as you can see there: iReal, Independent Remote Experiment Automation Labs, and Whole Kits, which are workstations for hands-on learning experiments. We put those in blended approach because we knew that we could use these kits in the classroom as well as putting them out into industry. And then, of course, as we've heard, the curriculum and development that goes along with this, you just can't pass on 20 of these trainers to a high school and expect the instructor who does the welding, the wood shops, and everything else to be able to make sense of some of these trainers. So Marilyn, can I have the next slide? So we have these 2 integrated distance learning in our South Central College academic program. And the area of study for troubleshooting diagnostics, we learned that our industry partners didn't want to hear about simulation. They said, if you're going to do online, as they put it, we prefer to call it distance learning. They wanted to make sure that somehow we got that tactile piece in there. And that's where these trainers come into play. So if we can get these trainers out to people and get worthy curriculum in their hands, we feel that we can have the same experience distantly that we have here on our campus with people coming for face-to-face. So the first thing that we started with was this iReal machine, and this was funded by our first NSF project. And we came up with an idea, not a new idea, but we just kind of took some edges off of technology that's out there already, and we came up with this system that we could tie into a MAP 200. And those of you who are familiar with like the Festo systems or the SMC systems, this is just a MAP 200. And what's behind in that photo to the lower right is that's where the stuff that we created that pushes everything out to the world, where people can log into the system, take control of the PLC. There's a camera a live image that takes place. And so you can, basically the student was given 30 minutes to troubleshoot up to 8 faults, and we would only have set 1 fault at a time, and then they were given a budget. And they had to go through, and we could tell by how they were tracking with their mouse if they were just, guessing, shotgunning, or if they were actually looking at drawings and taking on a systematic approach, kind of like I think what Dan's going to talk about with the Siemens approach. And so we could monitor that, and we could compare that to our face-to-face students and see if they were learning differently than our students that were taking things remotely. So kind of similar to what you've seen in the last presentation, we have this whole kit, and this started off to be a totally different system. This is one version of our trainer. These can be modified for some of our different classes like Electricity 1, PLC 1, PLC 2, even mechanical. We have some systems that can be mechanical. On a following slide, you'll see a pneumatic trainer that we've sent home with students with a tank that they can take to a convenience store and fill up with air. There are certain things that we can't do, like robotics, because we're trying to hold true to this whole simulation thing, where if you can't get it in your hands in front of you at home, then we just don't want to kind of broadcast that as far as what is face-to-face and what is distance. So the students still have to come in and take some of these classes, so we don't promote a full-on distance learning mechatronics program. Case in point, hydraulics. And I know there's some people who can teach maybe the theory part of that, but you just really can't get the tactile piece if you're not turning wrenches and connecting hoses up. So this is kind of our answer. I've got basically a safer, I call it safer, but a take-home version of this. You see a power supply in this picture over to the left upper corner, and there's 120 volts present there. So now I have wall chargers that we plug in, and everything is 24 volt systems when students want to check these out, or if we're taking these to high schools. Another thing that we're doing is we're working with the Faribault prison system, which is 50 miles away from our campus. We have a campus in Faribault as well, but 50 miles away from our main campus in North Mankato. And we're working with some inmates, and it's a second chance program. It's funded through a grant, and these trainers or similar trainers that are specifically set up for Electricity 1, they are using these to get credit for mechatronics. So hopefully when they're out in the world, and they can either take more mechatronics program courses, or they can get a certificate and get a job somewhere and get back into society. So we're finding these trainers have different applications, not only in our classroom and in high schools and junior highs, but also with a second chance program. So a couple of the other things that we have in our program is we do also require math. Basically, it's college algebra, physics, and technical writing. We think it's important that our students know how to write correctly. Obviously, our industry partners want that as well. So a lot of the times the LAS people will come down and interview the mechatronics instructors, and what they'll do is they'll make the students, as a project, create a user's manual or just a manual for a piece of equipment. So we also, just real quickly, have the Advanced Manufacturing Core. These are 4 2-credit courses, and when the student leaves, they get a certificate, and whether or not that helps them get a job, it's still something that might be recognized nationally, but those courses are quality, safety, maintenance, and manufacturing. So maintenance, awareness, and manufacturing. And Tooling U has some courses that fit into this. So if a student wants to do this totally online, depending on the instructor, they can use Tooling U as a tool to do that. So here again is just another view of our pneumatic one to the left there, and then a close-up of our PLC one. And you can see we're using an Allen Bradley system on that one, but we have a number of different PLCs we can insert into these trainers. We were checking these out from our bookstore. We treat them just like a book, and the cost of these, we're not selling them, but I would say that we probably have, depending on, we get some discounts for some things, but I'm probably looking at, with powder coat painting and some of the extrusion we use, we're kind of doing some high-end stuff on that, but about $2,000 probably for a PLC system. Obviously a lot lower for just electricity. So, and that again is kind of affordable. We try to do some things with grants with schools so we can kind of split the cost on these, but it's still more affordable than what some of the third-party people want for these trainers. So
hello everyone. My name is Dan Horine. I'm with Virginia Western Community College in Roanoke, Virginia. Our Mechatronics program is 11 years old, and we have about 75 full-time students in Mechatronics. I'm currently the PI of a project with NSF ATE called PACE Me. The acronym stands for Partnership for Advanced Career Education in Mechatronics Engineering. Next slide, Marilyn. The key part of our Mechatronics program is the relationship with business and industry. So we have relationships in the medical industry, the communications industry with optical cable, the automotive industry with Metalsa and Dynex. We're really focusing on probably agri-food and beverage as our focus of Mechatronics, and really process control is our new addition to our Mechatronics lab. This is just a quick overview of some of the students and where they started from and where they're going. We have a coordinated internship as part of the Mechatronics program. So when the students graduate, they're not green. They have some experience in the manufacturing industry. You see on this slide, we've only had one student as of a couple years ago for the bachelor's degree, but about 25% of our students are currently articulating and going on to get a 4-year degree. So we are a partner school. We will soon be a certified instructor training center where we'll be able to train faculty how to teach this certification for Mechatronics through Siemens. Our career studies certificate is aligned with that level 1 certification you see to the left. And then our associate degree in the middle is aligned with those 6 courses. So we offer the level 1 certification has been highly recognized by industry, as well as the level 2. And the next slide, Marilyn, if you'll go to it, I'll show how our curriculum aligns with that certification. Sorry, one more slide. So this is our full AAS degree in Mechatronics. We offer technical math, and then the second math is either technical math 2, or we offer the math 166, which is pre-calculus with trigonometry for our students that are articulating. We currently articulate with Old Dominion University and Purdue University. Quick overview of this EGR 105 class is a 1-credit class that I help students with all their math. And we've aligned really closely to a lot of engineering technology 4-year degrees. The last course is that coordinated internship, and then of course industrial safety. So Marilyn, I'll turn it back over to you.
Trying to say, or wanted to say, I hope that gave you a good picture of the 2-year college programs. We do have a pretty heterogeneous population of students, particularly the age group typically averages between 25 and 32, I would say, for an average age in different programs across the country. Depending if they have that high school connection, they may be younger, but I know our program at HCC here in Florida, the average age is 27. So a lot of working adults that have some experience that was mentioned by I think at least 2 of the presenters, by Dan and Doug, in their situations. But this is a growing, I'll say, movement in the 2-year college systems to meet the demand of regional industries that need technicians, need a workforce of technicians in their facilities. There's a step above most of the operators of 20, a few decades ago, where they need to understand a lot of different equipment at this and be able to work with the automated systems. And a lot of that can't be done or learned on the floor without taking a lot away from industry. So there's been a lot of change across the country, and it's just some of the programs that have grown up. So there's just about 25 on these last 2 slides, but you can see the variety of names. This particular slide has mostly Mechatronics. but there's another 24 around the country that we've researched recently too, and have identified as relatively new or newly transitioned from other programs. So again, to emphasize what we do, I went to the source, the ONET, which defines jobs and occupations for the Department of Labor, and the definition of an electromechanical technician. There still is no such official thing as a mechatronics technician in the United States, but operate, test, maintain, and calibrate unmanned, automated, servomechanical, or electromechanical equipment. So, in various different situations. So a lot of hands-on, as indicated by the kinds of training and education that they have. Down at the bottom, the last sentence says they may assist with engineering and testing and designing robotic equipment. This is not uncommon for the whole spectrum of the workforce to work in the design area. And this slide just captures some of the titles that are actually technically available in the ONET. These are not necessarily what industry will hire students as, but if we look for skill sets that have a lot of overlapping competencies, they would fall into this 17 and 4951 areas of the SOC codes. This is a little bit of repeat, so I'll move past this. Detailed work activities, what they do, we talked about that. And again, to emphasize broad industry sectors that hire the graduates of these programs. We have lots of students. We have very high placement rates, a number of students going on to four-year colleges. I think in all situations, but typically they go to work first, since these are mostly many working adults in the program looking to get ahead in the industry they're working in, or just starting a new career. And lastly, we have a community of practice too. It's called a Mechatronics Community Exchange. This is our website. We just have this one web page, and that we have a regular meeting on once a month during the academic year. It's just it's not really a webinar. It's more a conversation and sharing time on the different topics related to mechatronics in the 2-year programs. So you can Google that or email any of us to get more information about that if you're ever interested in learning or listening in and joining us, or even presenting something that might be interesting to the 2-year technical mechatronics programs. And that's our communities right as of last month, where the different schools are that participate. And lastly, we do a lot of mechatronics for 2 years. Institutions are highlighted at the High Tech Conference. It's in July this summer in Miami. And another reminder about the Mechatronics Community Exchange. So with that, I'll just say thank you. Here's our contact information. And I moved this. Don't know if we have any questions.
Thank you very much to all of you for your presentations. We have some questions. The first one is the question says, with all those new emerging technologies entering the curriculum, what traditional topics are getting de-emphasized or omitted?
So I'm going to turn to my 3 other speakers and see if one of them wants to take that. I'll ask Doug.
Okay. One of the things that we're seeing a big drive in is robotics, and we've got FANUC robots, ABB and KUKA, and I know those are expensive systems for new startup programs to try to go out and get, but we're seeing a lot more people want those things trained, and we're even to the point where we've sent one of our faculty members out, and he can certify in 2 of those areas right now, 2 of those robots, and we're going to get the 3rd very soon here. Some of the things that aren't really touched on anymore, or that's kind of gone by the wayside. in the mechatronics field of, fluid power and mechanical and electrical systems, and then of course the whole computer process, PLCs and such, I can't think of anything that's gone on the wayside. Maybe some of the other panelists can say, but we keep getting pounded by our industry people to just continue to teach troubleshooting, make sure that people understand the whole critical thinking path. And I know Siemens does a very good job of introducing that to the student. But robotics, that whole automation piece is really starting to emerge more. So yeah, I'm kind of at a loss for things that are kind of gone by the wayside. One of the things that we did take out of our program a couple of years ago or many years back, was microprocessor theory. It wasn't necessary. Maybe for the engineering programs, across the valley, but not for the mechatronics manufacturing. So thank you.
How about you, Dan?
We removed public speaking and a PE class to incorporate the added technical courses. Those are the only things that we've omitted to incorporate the changes in our mechatronics program.
I'll just chime in a little bit from what I see people doing. The robotics is definitely coming into play, and I think one thing that's happened is they're using those bigger systems to teach and to do more of the subsystems, the electrical and some of the mechanical stuff is now being taught in conjunction with the robotics as the application. So some of those more traditional fundamental courses could be said are being used in our skill sets are being used as kind of just in time learning in the bigger system.
Quick question for Doug, I believe. So you showed us those kits, PLC kits. Do you have any documentation on those for those educators who might want to replicate such kits for their institutions? Do you have any publications or just something like a report that we could share on our community website?
Yeah, we do. We have we put it together in it's not something that you learn at engineering school, but we put it together. One of the people that are working in our lab, we have an Excel spreadsheet, which makes it kind of where everybody can open that up. And we have all the components and all the manufacturers. So for instance, if you're looking at the PLC, and let's say it's an Automation Direct PLC, when you click on that, you'll see the photo. It'll even give you a link to the website for that manufacturer. You can go in there and kind of pick and choose what PLC you might want to use. But yeah, we do have something that I want to go back and look at it, make sure it's up to date, because we have so many of these different trainers now. I literally have trainers for various PLC classes and various electrical classes that I break out from time to time. And I know a lot of the other schools that spoke today have similar systems like that. But yeah, we would enjoy sharing that with the public. So
awesome, thank you very much. All right, so if there are no other questions, I would like to thank all the presenters. I really enjoyed your presentation. And yeah, thank you very much. As for our participants, thanks for participating in this webinar and all our previous webinars. So we will have a break for the summer, and we will be back. Hopefully we will be back in September at the beginning of the fall semester. Thank you, and have a great summer.